Hi everyone, welcome to Java Techie. If you are building microservices, then you might already using Kafka to handle communication between services. After all, Kafka is a super powerful messaging system, right? But here is the tricky part. What happens when your microservice depends on the order of events? Or how do we make sure events are consumed in the same order they are produced? This is something that confuses a lot of developers, and trust me, this is one of the commonly asked interview questions. So in today's tutorial, we are going to break it down step by step with a hands-on example. First, we'll see how Kafka can break ordering, and then we'll understand the right way to maintain it. Okay? Alright. So without any further delay, let's get started. So before we move forward, I am assuming that you already have a good understanding of Kafka components and how the internal flow works. If not, I strongly recommend checking out my Kafka for beginner playlist. You can see the link above. Watch that video first and then come back to this particular video. Okay? Now let's talk about the Kafka ordering problem with a simple and funny analogy. Imagine you order some food item like pizza, soft drinks, and some snacks. If one delivery guy bring everything for you, then your order arrive in the right sequence. Perfect. You will get everything at one shot. But if the restaurant send different delivery guy on different routes, you might get your soft drinks first, then snacks, and finally the pizza. It could be in any order because we never know which delivery guy will reach first, right? So this randomness in delivery sequence, that's exactly what we call the ordering problem. Now Kafka also work in the similar way. One partition, one delivery guy, order maintain. Because this is the person who will bring everything for you in one go. Okay? But if you have multiple partition, multiple delivery guy, the order can get messed up. Because the first delivery guy can bring the pizza for you, the second delivery guy will get the soft drinks and snacks for you. Who will reach first, we never know. So there is no order guarantee. Okay, I hope this is clear for you. So technically, Apache Kafka guarantees ordering of messages within a partition but not across the partition. Okay, this is the thumb rule you need to remember. So to make this more concrete, let's take an e-commerce order processing use case. A typical order lifecycle has events like order created, payment processed, order shipped, and order delivered. These must always arrive in this above sequence. Otherwise, business logic can break. Right? Now imagine we have a topic called order topic with three partitions. When the producer publishes these order events, Kafka by default distributes them using round robin partition. Okay, all the above events can go to any partition. For example, order placed and order delivered can go to the partition 0, order shipped can go to partition 1, and payment process can go to partition 2. Again, it can be in any order. Anything can come first and anything can go last. We don't have any guarantee on the order. Okay, now we have a consumer who can consume these events from topic. But since we have three partition, let's have three consumer instance where consumer 1 can read the partition 0, consumer 2 can read partition 1, and consumer 3 can read partition 2. This is what the default behavior of Kafka, having one-to-one mapping between partition and consumer, right? Now here is the catch. Since consumers process independently and different speed, so we can't guarantee which partition will read first by which consumer. Consumer 2 can read the partition 2 first, or consumer 1 can read the partition 0 first. There is no guarantee. You could see the event something like this. Payment process come first, then order placed, then order delivered, then order shipped. Or it can be in any order. This clearly makes no sense. You can't deliver before you ship, or you cannot process the payment before even placing the order. So this is exactly what Kafka ordering problem across multiple partitions. Okay. I hope you get the clear picture of what exactly ordering problem in Kafka. If yes, then let's understand different solution to fix this ordering problem in action. Okay. So let's go to our IntelliJ idea. So to demonstrate this Kafka ordering problem, I already created one producer and consumer example. If I will walk you through the example, go to the controller class, you will find one endpoint called process order where we will publish the event to the Kafka topic. Okay, so you have the producer, open the producer methods. We are using Kafka template and I am sending 4 different order object with the same order ID and event type you can find here order placed, payment, order shipped and order delivered. Okay, similar way I have defined the consumer. In consumer, we simply consume the event from this particular topic and we just print them. That's it. We have the simple logic here. Now all the Kafka configuration related stuff I have defined in application.yml, producer and consumer. This is the basic configuration. Okay. And you can find the topic information from application.properties file. That's it. Now here we'll understand first what is the Kafka ordering problem, what we discuss in theory. I'll prove that. Then we'll go with different solution. So let's start this application. But before that, first I need to start the Zookeeper and Kafka server, right? Let's start them. All good. Now let me start the application. Meanwhile, to visualize the events in Kafka, I'll open Offset Explorer. So if you see the console output, this is our consumer group, partition assigned to, these are the 3 partition 1 and 2. Okay, this consumer group, all the consumer part of this group assigned to these 3 partition. All good. Now let me clear this. Go to the browser. I'll open the Swagger. Now just open this. Try it out. I'll give the order ID something like ORD 123. Then send the request. Order has been published. Now go and check in your console output. For order 1 to 3, all the event went to partition 2. Can you see here? And it is already in sequence. Offset you can see here 0, 1, 2, 3. Order placed, payment processed, then order shipped and order delivered. Now if you will validate the same in Offset Explorer, go to the topic. Here if you check, all the 4 events came to the partition 2. That is expected because we are playing with a small events. So when I am saying small events, from producer we are only publishing 4 order event to the Kafka. That is the reason we are still seeing the ordering in Kafka. Okay, but in reality or in real time, if you will play with the bulk data or if you have multiple producer who writes to the same topic, you will find the ordering problem in Kafka. So what we can do to simulate this order break use case, what I will do in the application.yml, I will ask producer to publish the message to different partition using round robin partitioner. Okay. So if you will define these particular properties, your event will go to different partition. This is just we are doing artificial tweak to simulate breaking ordering in Kafka. Okay, fine. Now what I can do, I will just restart the application. So it started. Now go to the browser. I'll try for different order ID. Order, let's say 2. Okay. Now let me clear the console. Send the request again. Now if you see here, order 2 went to different partition. Partition 1 and partition 0, and you can see the order breaking here. Now in this case, since your event went to different partition, Kafka can't guarantee about the message ordering or event ordering. You can see here payment process fast even before order placed and order delivered, order shipped. This is completely meaningless. Okay. Now this is what the ordering problem in Kafka. Now how we can solve that? The first solution, use partition key. If you want all your order events to go to a single partition, then you can use the this particular order ID as a partition key. Then Kafka will route all those events to the same partition, keeping them in order. For example, this is your producer. You can ask Kafka, hey, if you are getting request for this order 123, which is nothing my key, then push all the event to a single partition. Then consumer can consume it and you will find the proper ordering of your messages. Okay. So let's try that out how we can use the partitioning key to publish the events and we can maintain the ordering. Now what I can do, go to the producer, I will copy this, I will rename the method process order with partition key. Okay. Then while publishing the event along with the topic name, I will also define the key as a order ID. Okay. I will define this particular key for all the event. It's not mandatory that you will give the order ID. You can give any unique key as part of your event, so that based on that particular key all the event will go to a single partition. That is how you can maintain the order. Now we have changed it. Now let me call another endpoint from controller. Okay, so I'll change the URL. That's it. Now let me restart the application. So it started. Now let me clear this. Then go to the browser and let me try for order 3. Okay, execute the request. Go here. Can you see the output? For order 3, request went to the single partition, that is 1. That is the reason you are seeing the sequence here. Does it maintain the correct sequence? Yes. The reason we are using partition key for events. So if you have a partition key, then all the event for that key will always go to the single partition. Okay. Now you might be thinking, okay, you did some artificial tweak and then you also go with the solution. That makes sense. But can you prove us without key, if I'll send huge data, it will go to the different partition, and with key it will go to the single partition. So for that what I can do, I already created one simple endpoint. Go to this order controller, then go to this producer, and what I'll do, I'll define two more methods, send without key, send with key. Now what I am doing here, in the controller class I am looping based on the input I will give. Let's say I will give 500 events, then we will send without key same order object. Okay, and we will observe whether it is going to the single partition or multiple partition. So as per our understanding, this should go to different partition. But for this one, if you see the second endpoint with key, when we are sending with key, I am giving here. So see, if you observe here, I am giving the order ID as a key. Okay. Now let's see what it behaves. Does it maintains the order or not, or it is going to the single partition or not? Let's see that. Let's restart the application. So it started. Let me clear everything. Go to the offset. Let's see how many records we have in our consumer. So if you see here, partition 102, all are being used, right? Now what we can do, let's go to the Swagger. I'll refresh this. Now we'll find two different endpoints, right? With key and without key. Now let's try without key and we'll see. Let's say order ID, I will give something like this, some random number. Okay, I'll try for 500. I'm sending 500 events for the same order ID. Now click on without key. That is what you need to remember. Okay, now send the request. Now if you go and check the console output, we'll see whether it went to different partition or not. Okay, now that we cannot validate in the console output since we have the 500 events, but what we can do, copy the ID, go to the offset explorer, go to your topic, execute this, do the filter. Once we filter, you can see here partition 0, then it use partition 1, right? So what we understand, without key, if you will send multiple events, then it can go to different partition. Okay, that is what, there is no ordering in events. Now let's test with key. So we have something called demo with key. Try it out. I'll give some different order ID. I'll again send 500 request. Execute the request with key. Now I'll filter this and we'll see whether it went to different partition or single partition. Just execute this and filter your events. Can you see here? All went to partition 0. Now to give you better clarity, I'll just execute this. Now see the number. Okay. Now I will send 1000 request again. Let's see. Since I use the same order ID, it should go to the partition 0. Yes, we are seeing here. Can you check the number of offset? 1733. I'll send again. You will find 2733. Can you see here? It will always go to the single partition. That is what the main things you need to implement. Partitioning key if you want to achieve ordering of events. Okay, so we are good here. From producer side, we are maintaining the order, and even from the consumer side, we are getting the proper order. But what if your consumer execute concurrently? Even if Kafka deliver in orders, your consumer code still can break it if you process message in parallel. For example, I have created one consumer order event consumer parallel. So it is listening to the same topic, but it is executing in parallel, or you can say in batch. Okay, so what I'll do, I'll just enable listener type batch. Then if you'll see here, what it does, it create the executor object. Can you see here executor service with 4 thread pool? Then each partition will execute by different thread. We don't know that. Either 2 partition can be executed by a single thread, or each partition can execute with the individual thread. That is what we have defined executor.submit. It is executing batch of records concurrently. So in this case, whether we will get the proper ordering or not. That is what another challenge is in Kafka. Even though you handle ordering from your producer side, but what if your consumer execute them parallelly? Then in that case, let's see what will be the output. Okay. So let me comment out the previous consumer, restart the application. So it started. Now let me clear everything. Go to the Swagger. I'll process with key, because process with key always maintain the order. Okay. Then my consumer is executing concurrently, and we want to validate that whether it maintaining order or not. If it is maintaining order, well and good. If not, how we can solve that? That is what the another solution. Now click on try it out. Give some order ID ORD88. Execute the request. Now if you'll check the console log, can you see here? Order 88, all the event went to the same partition because we are using partition key as a order ID, and if you can see the offset 4765, it is not in a sequence. Can you see here? Order placed, then order directly delivered without payment and shipped. How is this possible? This is completely meaningless. Okay, we are maintaining the order, all the event went to the partition because of our partition key implementation. But since my consumer execute each event concurrently, because of that the order again messed up in my consumer side. Now what happened internally? We have this, if you see here, partition 2, right? We have 4 events. Each events execute by different thread. That is the reason we are getting this sequence, which is completely incorrect. Now what is the solution? We can ask to Kafka, hey, can you do one thing? Properties, then marks, you can say marks pull records not 10, 1. What does it mean? It means you are telling to Kafka consume one record at a time. Okay, so I don't care whether you are executing batch or what, but I want my consumer process one record at a time to maintain order within a partition. But is this the correct way to implement? No. If you will define marks.pull record 1, it will slow down your listener drastically because you are forcing Kafka to fetch and process only one record per poll cycle. That kills the throughput, especially if you have high message volume. Okay, so that is not the recommended solution. You can still go for this if you want strict ordering. If your application need strict ordering, then still you can go for it even though you are implementing the batch consumption. Okay, but it is not recommended if you are getting the high volume of request and you want your things to be execute concurrently. So this is one solution for ordering, just keep a note of it, but this is not recommended. Now what is the solution? What we can do here? So what we can do, instead of execute partition by different thread, I will keep thread per partition. Okay, for example, I have this partition 1 and 2, 3, this much, right? Partition 1 always will execute by thread 1. Partition 2 will always execute by something, thread 3. This will execute by thread 2, something like that. Okay, I want to keep partition per thread. Okay, what will happen? In this way order per partition will be preserved, and this is how high throughput plus ordering is usually achieved in production grade application. Now how I can do that? How I can tell to the Kafka execute partition per thread? Partition request came to the partition 1 or event came to the partition 1, only thread 1 is responsibility to execute so that I will not messed up with the ordering. How we can do that? It's very simple. Now for that what we can do, I'll modify the same method only. Here I'll create a map. Okay, map of, so the key will be my partition integer, value is nothing my executor service. Okay, new concurrent hash map. Now since I have defined a map of key as a partition and value as a thread assigned to that partition, what I can do, I will just write the logic to assign thread to the partition. So keep this outside because we cannot keep it inside loop, right? So map needs to be initialized once. Now here, before we assign the task to executor, what I'll do, I'll check partition executors dot compute if absent. Let me add it like this. Compute if absent, assign the partition, create the thread and map it to the value. Okay. Next time when request come to the same partition, it will check in the key. Okay, this partition is already mapped to this particular thread. He won't assign any other thread. That way you will get the correct order. Now I don't need this executor, remove it. I'll simply call submit. All good. So we segregate thread per partition. That way you will expect ordering in Kafka even though your consumer execute concurrently. Okay, let's test this out and we'll see the result. But before that, since this is the batch processing, I'm just writing it, it's not mandatory. You can define the properties. The default value of marks poll record is 500. You can define that. Okay, so in production usually you can keep 500. It depends on the volume coming to your topic. So since we are executing using batch, you can define some number. You can also comment these. It is not mandatory in our example. Okay, but just have a note of it. You can define marks poll records some number based on your need. Now let me restart the application quickly. So it started, clear everything, go to the browser, process with key. I'll try for order 99. We are expecting, since my consumer executing concurrently, still we will expect the ordering of events. Let's run it. Go to the console output. Order 99 ORD 99 went to partition 1, that is expected because we are using partition key as this number. Then see the sequence 1, 2, 3, 4. See the offset 375, 76, 77, 78. And event type order placed, payment processed, order shipped, and order delivered. Are you getting proper order or not? So there are different way you can maintain the ordering in your application. Make sure the first key things you need to define the partition key. Second, if in case your consumer execute the things in concurrently, then make sure to assign thread per partition. Apart from that, you can also implement some sort of approach to avoid duplicate messaging with order. Mostly in case of retry, you can enable idempotence and you can define different type of acknowledgement. Anyway, that's another important topic and I'll create a separate video based on your interest. But I hope for now you are clear with the Kafka ordering problem and its solution and confident enough to give a nice smile when your interviewer asks this question to you. Well, try out this example and let me know in a comment section if you have any doubts.